Good morning, everybody. Today is day 26 of Math 133. We are going to do the Chapter 11 project today. You will find that in your course pack on page 578, 578. Um, Before we jump into that, uh, I'm recording this morning session. There's not an evening session, so if you're watching this on the recording, feel free to message me any questions on Remind. You can email me. I just don't respond to email as quickly, so uh, but yeah, if you have questions, feel free to reach out. Uh, if you are watching this on the recording and you also missed Tuesday's class, then that means you're going to have to do the discussion board. So the discussion board for week 13 is here. So if you attended one of the Zoom sessions in person on Zoom this week, then you don't need to do the discussion board. But I apologize to anyone in the evening class who has to watch this recording and then have to go do the discussion board. But I mean, it's still helpful. So okay. So we are coming up on the final exam. The final exam is in 2 weeks from today. Um, so I've said in the past that you can turn in assignments late, and when you turn in an assignment late, I take 1 point off for each day that it is late. Okay. I've also said that if you turn something in more than 3 weeks late, that I will not accept it. Okay. Um, that's true of all the assignments up to this point. Since we are now only 2 weeks away from the final, that number is going to change. Um, I have to have my final grades turned in on Monday the 4th, Monday, May 4th. So if you turn, so the last day that you can turn things in and I will still grade it is Friday, May 5th, or May 1st, Friday, May 1st. Okay. Um, so anything turned in after that, I'm sorry, I'm not going to be able to grade it. I have a lot of grading to do that weekend. I'm also going away that weekend. I don't know how it's all happening. So anyway, the final exam is on April 30th. You can also take it in the testing center that week. May 1st is the last day that you can turn in assignments. May 1st is also the last day that you can take the final exam, and then I have to grade everything. Um, the sample final, which we're going to work on together in Zoom, the sample final is one of the worksheets, and it says that it's due April 30th. I will accept it on May 1st, but that's it. So usually you can turn things in late, not the sample final. That needs, if you have part of it done and the rest of it's not done, but you know, it's May 1st, turn it in. Turn in what you have. Okay. So, and that's true of all of the assignments. If you are behind on anything, now is the time to start catching up because once May 1st gets here, yeah, get it all turned in. Okay. So today's project, chapter 11 project, uh, like I said, I'm not going to be able to set that 3 weeks late. So, yeah, May 1st. All right. I think I've hammered that point home. So, most of you guys are up to date on your assignments and haven't got anything that's late, so you're fine. But yeah. Um, okay. So then we also have lecture notes that you need to do, 11.3 lecture notes and the flowchart lecture notes. And that's it. This is the last lecture notes. So so yeah, exciting, right? But uh I've said so just like with the midterm when we paused on the lecture notes, don't just be like, okay, well, I don't have to do that anymore. You've got that time set aside in your schedule to where you were watching lecture notes, right? It takes time to do those. Keep that time in your schedule blocked off so that you can use that time to study. Start studying for the final exam, catch up on anything that's late, fill in, your 8.5 by 11 piece of paper, get everything ready. Okay. So, Yes, you don't have to do lecture notes after you've turned these two in, but I would keep that keep working on the math the same amount of time each week. Okay. This one, the Chapter 11 flowcharts lecture notes, is an important one because there are three flowcharts that you're going to be filling out that you can have with you for the final exam. You can kind of think of them as part of your exam notes packet, but they just kind of give you a little bit of help on what do I do with this situation? What do I do if I have this situation? Okay. So make sure you definitely get those filled out. Okay. Filled out and, have them uh, on paper so that you can bring it to the final exam, right? So, um, all right. I think that's everything for our upcoming stuff. So for our Chapter 11 project, it is on page 578. In addition, this Chapter 11 project is about M&Ms and Skittles. So this is our last time we're going to get to talk about M&Ms and Skittles, but you'll need to go get the numbers that you had for that data. Okay. So we've used these same counts for Chapter 9 and 10 project. Now we're going to use them for the Chapter 11 project. And now you're going to see why we needed you to get the red bag of Skittles because it shares the same colors as M&Ms. So the both M&Ms and Skittles have oranges and greens and yellows and reds. Um, so the Skittles doesn't have blue or brown, but that's fine. Okay. We're just going to focus on those four. Okay. Um, In addition, if you click on the Chapter 11 project in Canvas, there are two links to StatCrunch, one for confidence levels and one for significant levels of significance. So you'll need to click on those, and I'll drop both of those in the chat. But obviously, if you're watching this on the recording, you're not going to have the chat in front of you. So you're going to need to uh, click on the Chapter 11 project and click on these two links. Okay, so the other one, levels of significance, is this one. That in the chat as well. So there's those. Um, so I think we've got everything that we need. Let's go to page 578. And so in chapter 9, we talked about confidence intervals for a single sample, a single population. For chapter 10, we talked about hypothesis testing for a single sample. Or a single population. And chapter 11, we're going to be talking about what happens with confidence intervals and hypothesis testing. So it kind of merged them into one chapter instead of two separate chapters. But what's different about chapter 11 is we're talking about two samples or two populations and comparing those and saying, are they similar or are they different? Okay. So another example would be like if I wanted to look at the average height of men and women. Those are two different populations, and I would need to get a sample of men, a sample of women, find those averages, and then I can ask myself, okay, is the average height of men and women similar or is it different? Okay. Um, so that's what we're talking about in chapter 11. All right. So, uh, to start with, we're going to need to fill in all of our uh, numbers that we collected, all of our counts that we collected for M&Ms and Skittles, but just for green, orange, red, and yellow, because those are the ones where those are the colors that are in both types of candies. Okay. So first of all, I need my sample sizes. So N1 and N2. Now, my numbers were 140 M&Ms. That was my total. And 238 Skittles. Okay. So I'm going to put those in my N1 and my N2. Okay, my sample sizes. Uh, and then I'm going to write how many green M&Ms I had. I had 23 green, 28 orange. They didn't put these in the same order. That's annoying. I don't know why they just do it in alphabetical order. I mean, it's alphabetical on the Chapter 11 project, but it wasn't on this. So anyway, it's fine. Uh, so here's my M&M counts for those four colors. I also need my skill. So I'm gonna skip the P hat for a second. I'll come back to that. I'm gonna do my Skittle counts as well. For green, I had 54. For orange, I had 42. Red, I had 52, and yellow, I had 48. Okay. Um, so next, I need to get my p hat for each of these. So I would do 23 divided by 140, 28 divided by 140, 23 divided by 140. And then over here, I would do 54 divided by 238 and so on. So I'm going to get four different p hats. And then I need to subtract those. I'm going to be a little bit lazy and use Sheets for this. So Google Sheets, that is. So Sheets. And I'll just start a new blank spreadsheet. If you have Excel, you can do this in Excel as well. Um, but I'm going to copy my colors and numbers here that I had in this Google document, and I'm going to put it over here in my spreadsheet. All right, and that's for M&Ms. All right, and then I'm going to also copy my Skittles. Put those in here. I don't need the total. I don't need purple. I don't need my brown. And I don't need blue. All right. And I want these all lined up. So I'm going to do it like this. There we go. Um, Still not in the right order, but that's okay. I'll just write them down. So, um, all right. So my P hat for M&Ms, uh, that looks like it says fat M&Ms. It equals uh X divided by my total M&Ms, which was 140. Right now, let me type that. Oh, because I don't have a number lock on. There we go. And I'll just copy that formula down. So what I typed was equals, and I clicked on cell B2, divided by my total M&M count, which was 140, and now I have all those. So here are my P hats for M&Ms. So I'll write those down. So I had 0.2, I had 0.164, 164. Oh, they're all 164. All right, fine. Yeah. Is this Google Sheet that I'm looking at here in Canvas? No, this is a blank Google Sheet that I just went to Google and I said, hey Google, open up Sheets for me. And I don't want to try it for free. Go back. I just want a Google Sheet. There we go. Google Sheets. There we go. So I Googled Google Sheets and just open a blank spreadsheet. And then once you're in here, the formula, I made sure that I got rid of my blue and lined everything up. And then I did equals, and then I clicked on cell B2, and I divided by my total, which was 140. Mine was 140. Your numbers will be different, but that's fine. All right, so my fat Skittles p hat is equals. I'm going to click on my X value for orange, which was 42, and divide by my total number of Skittles, which was 238. And I'll copy that formula down. Google had the right idea for that one, so I used it. And here are my p hats for Skittles, 0.176. And to copy those onto my paper. Okay. Now, if you didn't want to do Google Sheets, that's totally fine. You would just in your calculator type in, I would type in 23 divided by 140. Oh, see, and this is why, shoot, I didn't put them in the right order. Dang it. Humbug. All right, so when you're copying it, make sure you're careful about which ones you write. So my so on the project, it's green, orange, red, yellow, but on the like my Google sheet here, I have it in the other or I have it in a different order. So all right. What's this? All right. Green for me was not this first one, it was this one. So two, two, seven. All right, what was my orange? 0.176. That was the last one. Two, two. There we go. Okay, now I've got them in the right order. Anyway, going back to what I said a second ago, if you didn't want to do it in Google Sheets, that's fine. You would just do it in your calculator, 23 divided by 140 and write out your result, 28 divided by 140, and you just got to do all 8 of those. So I liked doing it in Google Sheets because I could just copy and paste my formula, but then it screwed up the order I wrote them on my paper. So I didn't save myself any time. That's okay. Hopefully it'll save me some time on this part. So for this part, it is the difference, which is my p hat minus p hat. So I'll do equals the p hat of M&M. So I'm going to click on that. So that's cell C2 minus the p hat of Skittles. So I'm going to click on the p hat of Skittles for the same color. And so the difference for my orange was 0.02. And then I'm going to copy that formula down, all of these, and I'm going to make sure I write them in the right spot. So green for me had a difference of negative 0.063. So a difference of 6%. Negative 0.063. My orange was this one, 0.024. Red is this one, 0.054. And my yellow was this negative 0. So the formula for this one was I just subtracted p hat minus p hat. Okay. And if you didn't want to do it in sheets, that's fine. You could just do it in the calculator. You need to type in your calculator 0.164, which is, or whatever you got for the green p hat, minus whatever you got for green Skittles, 0.227. I subtract those two and I get this. Okay. Um, you'll notice that if I do it here, I don't actually get negative 0.063. I get negative 0.06 4. And that's because of rounding. I've said before, you want to round at the end. So if I round this number and then round this number and then continue doing math where I subtract them, you get some rounding errors. It's not a huge deal. I'm not worried about it. Okay. Um, so over here in Google Sheets, this wasn't rounded. You can see I have a million decimal places here. So I only did the rounding at the very end when I wrote out my final answer. So either way is fine. I'm not worried about it. Okay. So all right. So we wrote out our colors, our counts that we had from when we counted our M&Ms. We calculated our p-hats, and then we subtracted the difference. Okay. What we're trying to do is we want to test and see, is the proportion of green M&Ms and the proportion of green Skittles different? Is the proportion of orange different? Okay. Um, if it's different, then that means that the populations are different. Okay. If they're similar, then that means that uh, you know you the proportion is the same. So, like, let's say we weren't talking about M&Ms and Skittles. Let's go back to what we were talking about before. Whereas, let's say we were looking at um, we were trying to figure out who we should be advertising to, who we should be campaigning for our next election, right? So if I am trying to gain additional support, and whether I'm Republican or Democrat, either way, um, so if I wanted to see what percent of people are going to vote Republican if you are married or single. Those are two different populations. And so I could test and see, are those proportions the same? In which case, marriage isn't important in my political view. Uh, or are they different? Are people who are married more likely to vote one way or the other? That might be helpful information for my campaign. Okay. So here we're talking about M's and M's and Skittles. So it's not exactly helpful, but we want to see if these proportions are different. Okay. All right. Question 2, circle the color that showed the largest difference in proportions between M&Ms and Skittles. Just ignore the plus or minus. So whichever number is largest. So this one for me is the largest. It's, if I move my decimal two places, 6.3%. So for me, it's green. This one's 2%. I actually had a higher proportion of orange M&Ms than Skittles. That's crazy. 3%, and then this one's -5%. So circle the color that showed the second largest difference in proportions. Again, just ignore the plus or minus. Whichever of these numbers is second largest. My second largest was the yellow one. Okay. So you take a look at these differences and just figure out which color is the biggest and circle that one. Okay. All right. So I'm going to be using this one. Um, let's see. I'm actually going to start with using the second one. So I'm going to be using this one for confidence intervals. And that's what we're going to talk about first. Okay. Uh, and then we'll also talk about that for sample sizes. We'll switch to this one for hypothesis testing. Okay. So anyway, so I'm actually going to start for my part of my from on my part of the project, starting with yellow. Okay. All right. So I'm going to make sure I have this somewhere I can get to it. And next page is page 579. Use the StatCrunch, Math 133 random confidence levels to generate two different confidence intervals. So do data, sample, confidence levels, and a sample size of 2. Okay. All right. So I dropped that link in the chat for you. It's this one, random confidence levels. Okay. It's the first one. Uh, so don't get these mixed up. So we have two files here. So one is levels of significance and one is confidence levels. And we've said before that those are related. Your confidence level plus your level of significance adds up to 100%. So your confidence level is it plus your alpha, right? Level of significance is the alpha. The level of confidence, your confidence levels should be large numbers. So 70%, 80%, 95%. This goes up to 99.8%. Okay. So use this one for question number 4, and it should be 2 big numbers. So we're going to click on data, sample, select the confidence levels, and we're going to do a sample size of 2 and hit compute. And it's going to pick 2 random numbers for you, and you're going to write those for question number 4. So I got 96.3%, and I got 78.3%. Okay. Once again, that was data, sample, click on the confidence levels, put in your sample size of 2 and hit compute. And it's going to give you 2 numbers, and you're going to write those right here for the 2 confidence levels, 2 confidence levels they gave you. This first one we're going to use for confidence intervals. And then this one we're going to use for sample size. Okay. Which will be on, I think it's like question number 9. So, all right. Use the StatCrunch file level of significance to generate a random level of significance. Do data sample level of significance and do a sample size of 1 because we only need 1 number for this. So level of significance, that's your alpha, and that should be a small number like 10%, 5%, 1%. Okay. So that's this one, 10%, and it goes down to like 1.1. Okay. 1.1%. So I'm going to do data, sample, select my level of significance, and do a sample size of 1. I'll hit compute. And so my level of significance is 0.087 or 8.7%. Okay. I'm not sure. So this one is written in percents. This one's written in decimal form. That's annoying. Okay. Anyway, once you've got that written down, we don't need those files anymore. So we're going to use level of significance. That is used for hypothesis testing, right? Okay. All right. You want to construct a confidence interval for the difference in proportions of M&Ms and Skittles for the second largest color. That was from number 3. So my second largest color was yellow. Okay, so I'm doing yellow. I'm just writing a note here for myself that I want to make sure I'm looking at the yellow numbers. Yours will be different, right? Whatever one you circled for number 3. So second largest difference color, verify whether all requirements are satisfied for constructing this confidence interval. So if you haven't filled out your chapter 11 flowchart notes yet, that's fine because I just assigned it to you. But there's a chapter 11 flowchart that will say, okay, if you're doing this, here's the buttons you click on in StatCrunch. If you're doing something different, here's different buttons. So I want to do a confidence interval for 2 proportions. What page do I need to look at for that? We want to construct a confidence interval for the difference in proportions of M&Ms and Skittles. That's that. So this is page 260. Yep, Rachel's got it. Good. Page 260, confidence interval formulas for two populations. Okay, there's three different ones depending on your situation. We are looking at proportions, so we're doing the stuff at the top. Okay, if we were doing means, there's two ways you can do means. This is means where it's independent, and this is means of matched pairs. What's the difference there? So let's say that, I am trying to help, with a election, election campaign. And let's go back to my earlier question. I'm trying to decide, should I be um, should I be advertising to should I be focusing my message with men or women? Are men gonna vote for Republican more often, or are women gonna vote for Republican more often? Or is it the same? Okay. So that's what I'm comparing. I'm comparing those two different populations. And I can calculate the p hat for a sample of men. I can calculate the p hat for a sample of women. And then I subtract those two p hats. If I get zero or a number close to zero, then that means that the proportion of who's going to vote Democrat or Republican is the same. Doesn't matter if you're looking at men or women. Okay. So in that situation, that's independent. If I pick this man uh, for my sample, that doesn't affect my other sample, which is the women, right? I'm gonna uh, get a sample of women, ask them who they're gonna vote for, and I want to see the proportion between what percent are voting for this, what percent are voting for this. Okay, that's independent. Matched pairs is where this person from this sample matches up with someone from the other sample. So an example of that would be, I want to see um, for married couples if there's a difference in who's voting for what in the household. So, well, okay, you can't really do that for proportions. So maybe I'm getting a little off track, but um, in that situation, if I select this married man, I don't want to just I need to make sure that his wife is in my other sample, and those are matched. Hopefully, I'm explaining myself. Those are not independent. Those two samples are not independent. Who you select in the first sample affects who you're going to select in the second sample. Okay? So those are dependent. Anyway, but you can't really talk about that for proportions. That would be for means. Okay. Anyway, we are going to be focused on this stuff at the top. So we're going to do stat, proportion stats, two samples with summary. Uh, and we need to check all these different things. Okay. So verify the conditions are satisfied for constructing this confidence interval. We need to check and make sure that our samples are random. They are independent, and that's independent of each other. Okay. Also need to check and make sure that they are independent of the population. Okay. So that's what's going on right here. Random sample, independent samples, samples independent of the population. We've been doing that for a while, right? That's 20%, or sorry, 20n less than n. In other words, 5% of the population. And we also need to check that they are normal. Okay. So, first of all, we need to know if both samples are random. Yes, they are. Both samples are random because, oops, I gotta finish writing. Both samples are random because every candy had equal chance of being in the sample, right? Being selected. Okay. Next, for independent, there are two ways that your samples can be independent. One is if you have two groups measured once. The other is if you have one group and you measure it twice. Okay. In which case that's not independent, that's strictly dependent. Okay. Either of those is fine. Okay. In our case, we have two groups measured once. We have two different samples. We have our M&Ms and our Skittles. We counted each of those once. So two groups measured once. Those are independent. Okay. There's no overlap between the two samples. Okay. All right. Next is independent of the population, and this is where we check and make sure that our N is less than our other N, right? Our sample N is less than 5% of the population N. So for M&Ms, I'm going to write NM and NM just so that I can keep track. And then over here, I'll do 20 NS less than NS. So this is the sample size for M&Ms, the population size for M&Ms, sample size for Skittles, population size for Skittles. So my sample size for M&Ms was 140, and my population is just all M&Ms. I don't know what the number is for that. It's in the trillions, right? And then over here, I have 20 times, I had 238 Skittles. Is that less than all Skittles? Yeah, they never give me enough room in these boxes. That's okay. This one's 2800 less than all M&Ms. So that's a yes, right? And then this one is 0674. And that is definitely less than the number of Skittles. So both of those are yes. So yes. Are my samples independent of the population? Yes, they are. Okay. I also need to check that they are normal. So NPQ has to be bigger than 10. And I need to check that for both samples. So up here I wrote NM. You could write N1 if you want. So you could write N1, P1, Q1, and then NP, N2, P2, Q2. That's what it says on page 260, right? But if you want to make it more specific, like you're like, all right, but I don't want to get confused of whether M&Ms are one or two. You could write M, M, M there, and then S, S, S. Okay, either way is fine. Or if you have men and women, you could do M and W. Okay. Um, all right. My sample size for M&Ms was 140. Now, if we're doing hypothesis testing, you want to use P0 and Q0. You want to use the null hypothesis, okay? But I don't have that here, so I'm just going to use P hat and Q hat, okay, for both of them. So my P hat for M&Ms, this is why I wrote which color I was looking at. My P hat for M&Ms for yellow is 0.164. That would make my Q hat for yellow. Now I gotta go calculate that. Maybe 0.6. My Q hat for yellow is 0.836. And while I'm here, I'll do 140. I gotta multiply these out. 0.6 times 0.836. And I get 19.2, which is bigger than 10. So that is good. That's a yes. Okay. I have to check the same thing for Skittles over here. My Skittle sample size was 238. My p hat for Skittles, I'm doing yellow. So whatever one you circled for number 3, that's the color you want to write down. My p hat for yellow Skittles 0.202. And then my Q hat for that would then be 1 minus that, which is going to be 798. Multiply those together. 238 times 2 times 178. 38.4 is bigger than 10. So good there. So if I get both of those are good, then I get a yes. Now, if either one is a no, then that means that normal is a no. Okay. All right. That was a lot to check. Usually when we have been checking these, we only need to check random, independent, normal, and you had to check those 3 things and you're done. Here we have to check 7 things. We have to check that the M&M's is random, Skittles is random, that's 2. And then independent, I had to check that. I had to check independent of the population for both of these, and then independent and then normal for both of these. It's a lot to check. Okay. But all of those are yes for me. Uh, if you got a no for this one, that's okay. We've seen before where, you know, our M&M counts or our Skittle counts might have been too small. Um, if that's the case, then, you know, if you were an actual researcher, you would then say, oh, well, our sample size is not big enough. We need to go and, you know, get a bigger sample. Okay. But for our case, regardless of whether you met the requirements or not, we're going to uh, calculate our confidence interval. Okay. All right. So for confidence interval, we're going to use this level of confidence, or whatever you had for number 1. Okay. So regardless of whether or not, oh, that's from last year. I've got that in front of me so I can keep track of what page things are on. Regardless of whether or not the requirements were met, number 6, construct a confidence interval for the difference in proportions of your chosen color for M&Ms and Skittles using confidence level number 1. Don't show your work, just do StatCrunch and get your result. Okay. So I'm just gonna remind myself I was doing yellow. So, because I want to make sure I type in the right numbers. So whatever you circled for number 3, okay, you're still on that. And then my confidence level, number 1, I got 86.3%, which as a decimal is going to be 0.963. So that's my confidence level. Okay. Now that I've got that, we said we were going to do page 260. That's where the StatCrunch buttons are. Stat proportion stats to sample with summary. Stat proportion stats to sample with summary. All right, so doesn't matter. I just need a blank StatCrunch at this point. We'll go to stat proportion stats to sample with summary. In my first sample, I'm looking at yellow, so I had 23 yellow M&Ms. I had 140 total M&Ms. I had 48 yellow Skittles, and I had 238 total Skittles. Am I doing hypothesis testing or confidence intervals? I'm doing confidence intervals right now. We'll do hypothesis testing in a little bit. We're doing the confidence interval for P1 minus P2. My level was 96.3. And I'll hit compute. And I get my lower limit and my upper limit. So my lower limit in this case is negative 0.1225 decimal places. All right, 0.12230. And my upper limit 0.04751. So there's my lower limit and my upper limit. Write those in. Okay. There's my result. So this is the confidence interval for yellow, the difference in the proportion of yellow M&Ms and Skittles. Okay. So if the proportion of yellow M&Ms and Skittles is supposed to be the same, like if I had done two samples of M&Ms, I got a bag of M&Ms and another bag of M&Ms. Those two samples are coming from the same population. Yes? Population is all M&Ms. So I have a bag of M&Ms and another bag of M&Ms. You should expect that the proportion of yellow M&Ms in the first bag should be around the same as the proportion of M&Ms from the second bag. Now, are they going to be exactly equal? No, they're not. Okay, they're going to be in some range. That's what this confidence interval is telling you, is you are 96% confident that the difference is going to land somewhere between 12%, negative 12%, and positive 4%. Okay, that's at least that's the numbers I got. Okay, that's if they were coming from the same population. When the proportions are exactly the same, p hat 1 minus p hat 2 gives you 0. Okay, so that's why we're looking at that, and that's why we are trying to figure out, okay, is it 0 or not? Okay, so that's what we're going to check next. Okay, because I'm not looking at a bag of M&Ms and a bag of Skittles, or sorry, a second bag of M&Ms. I'm looking at a bag of Skittles. Those are not coming from the same population. So the question is, these two populations are different, but is their proportions the same? Okay, that's what's happening. So, Willy Wonka is back again. Uh, I guess maybe he is the bad guy, right? He endangers a lot of children. And anyway, claims the M&Ms and Skittles have a significantly different proportion for my chosen color. My chosen color for number 3 was yellow. Does your confidence interval support his claim? Okay, so that depends on whether 0 is contained in my interval. Okay, so here's my number line right here. Okay, and for me, 0 is right here. Okay, if my confidence interval is like over here or over here, if 0 is not contained in my interval, then that means I am 96% confident that the two proportions are different, significantly different. Right? If 0 is in my interval, then that means that there's a chance that the proportions are the same. Okay. So for me, I have negative 0.12 is over here and positive 0.47 is here. So in my case, 0 is in my interval. I'm 96% confident that the true difference in proportions lands somewhere in this range. I don't know where, but I can't say that M&Ms have more yellows or Skittles have more yellows by proportion, a bigger percent of yellows, because 0 is contained in there. So for me, 0 is contained in the interval, and I do not support that. Okay. Now, on the other hand, last semester, I had these numbers, negative 10% and negative 1%. those two land here and here. So I don't know what the true difference is. It's somewhere in here. Maybe it's negative 10% or negative not 5% or negative 1%, but it's not zero. Zero is not in my interval. So in that case, I would choose this answer. Uh, so you'll choose one of these answers depending on where zero lands. Okay, so it's easy to tell if zero is in your interval. If both of your numbers have the same sign, so if this is a negative and this is a negative, then that means that zero is not in your interval. If one's negative and one's positive, that's what I have. If one's negative and one's positive, then zero is in your interval and you would circle this one. Okay. Okay. So that is that's our confidence intervals. Now, um, this confidence interval is gigantic. Okay. It goes from negative 12% up to 4%. That's a difference of 16% for me. Okay. Yours might be different. Yours might be smaller or wider, narrower, or whatever. But uh, this is a range of 16%. Uh, that's huge. Okay. So let's say that instead you want to be a little more accurate and you want to be within a 2% margin of error. So in other words, you want your confidence interval to go from like -2 to +2. Okay. So like a much thinner confidence interval. Okay. Because you want to be more accurate, you want to be more confident. Okay. So you want to redo this test basically with a larger sample size. How big of a sample size do you need? That is what we are going to check next, okay? So we're looking at sample size. So using your proportions of M&Ms and Skittles for the second largest difference. So I'm still using yellow or whatever one you circled for number 3, okay? So you're still using that as prior estimates and confidence level number 2. So I said we're going to use this one for sample sizes. This one's for confidence intervals. We did that one already. Now I'm going to use a confidence level of 78.3%. Calculate the minimum bag size for each type of candy required to ensure that the difference of proportion of the second largest difference of color for M&Ms and Skittles is within a 2% margin of error. So for this one, I need to know which page of my exam notes packet am I looking at. So this will be on page 261. Chapter 9. So if you have a single sample, how many M&Ms or how many people do you need to sample? That's this formula. We have a double population. So we have M&Ms and Skittles. We're looking at them together. How many do we need? We need to use these formulas down here at the bottom of page 261. Okay. So if I have prior estimates, which I do, I have my p hat and q hat from my first sample. And we're saying, well, this sample just wasn't big enough, okay, because your confidence interval is too large. So we need to get a smaller confidence interval. We're going to use this formula if you have a prior estimate. If you have no prior estimate, then it's this one, which is basically just 0.25 plus 0.25, which is 0.5. Okay, that's where that comes from. But we are going to use this one. So we need the formula. We need the substitution. And we need our results. Okay. So the formula is at the bottom page 261. It's the one on the left. So our formula is n equals n1 equals n2 equals p hat 1 q hat 1 plus p hat 2 q hat 2 and then Z alpha over 2 over the error squared. All right. For substitution, so this right here, this n equals n1 equals n2, that seems a little confusing, and I apologize for that. All this is saying is you are going to get the same number for both sample sizes for M&Ms and Skittles. So our first time doing this, I got a different number for each, which is fine, right? You don't, when you buy a bag of M&Ms, you don't get to decide how many are in the bag, okay? Um, when we're calculating sample sizes, this is the minimum sample size. You are allowed to buy more than that. But in order to be sure that your result is within 2%, in order to have that level of accuracy, this is the minimum sample size. And it's going to be the minimum sample size for both. Okay. So you don't, the second time you run this, you don't have to make sure that your sample sizes are the same. So you can buy, 1,000 M&Ms and 200 Skittles as long as, this result says that 200 is fine. Okay. So I'm not going to write all that out again. I'm just going to write n equals. Okay. All right. My p hat for M&Ms, and I'm doing yellow still, was 0.164. So my q hat, I had that a second ago, right? Was for M&Ms was 0.836. My p hat for Skittles, and I'm looking at yellow, was 0.202 times my Q hat for Skittles was 798. The margin of error as a decimal is 0.02. So 2%, you change that to a decimal is 0.02. My Z alpha is going to depend on my confidence level. I'm doing a confidence level of 78%. Your confidence level will be something different, okay? But the steps to find your Z are the same, right? We need to use the normal calculator. So I'm going to come over here and I'm going to do stat calculators normal. Stat calculators normal. I want a between. Confidence intervals are always between. And my confidence level from question number 4, I had 78%, 78.3%. That's going to give me my Z value. 1.2345. That's crazy. 1, 2, 3, 4, 5. Okay. Nice. 1.2345. All right. So that was stat calculators normal, and you're going to use the confidence level that you calculated, confidence level number 2. Okay. Um, then I get to put all this into my calculator, right? All right. Let's see what I get. All right. I'm going to type this whole long thing out. Here we go. 0.164 times 0.836 plus 0.202 times 0.798. Close my parenthesis times open a new parenthesis. 1.2345. And divide that by my error. Close my parenthesis and square it. And there is my result. I get n equals 1136.2. Okay. Okay. So that is not my answer. When we're doing sample sizes, you always round up. to the nearest integer. That's what it says on page 261. So I need to round this up. It will be 1,137. Now, is that 1,137 M&Ms or Skittles, or can I just do a combination? Like, can I get like 1,000 M&Ms and 137 Skittles? No. This is the minimum sample size for both, so I need to write it out as 1,137 M&Ms, and I also need 1,137 Skittles. Okay. So in order to run this test again with the level of accuracy that I'm asking for, I need to go by at least 1,000 M&Ms and at least 1,000 Skittles. Okay, which is a lot, but this is way more accurate. We're looking for an accuracy that's way better than the first time we ran this. Okay, and to get more accuracy, larger sample size is more accurate. Okay. Now that I've got that, I've got a couple questions to ask about those sample sizes, so don't lose your sample sizes yet. Question number 10 is asking, oh wait, yep, totally screwed that up, didn't I? Should be the same number. I don't know how I did that. There we go. Thank you, Jalen. Yeah, those should totally be the same number. That was the whole point of the N1 equals N2 thing. All right, sorry about that. Page 581, question number 10. Suppose when we were doing number 9, so number 9, we were calculating sample size. So while you're doing the sample size, if you had no prior estimates for the sample proportions, would your sample size have been smaller, larger, or the same? I'm going to ask you guys, smaller, larger, or the same? You may know? Please. So when we have no sample size, no prior estimates, your sample size will be larger. Okay, let's check that. So if I come back over here and get rid of all this was my prior estimates. These were my p hats and q hats. If I didn't have any of those, this was the first time I'd bought those M&Ms and Skittles, I would put it in as 0.5. And now my sample size jumps from 1,137. Now it jumps up to 1,905. So that means I'd have to buy 800 more Skittles, which is a ton, and 800 and more M&Ms. Okay, so it's more expensive. A larger sample size is more accurate, but it's more expensive. And so, if we can get away with a smaller sample size, it would have been better if we had a prior estimate. Okay, now if your prior estimate just happens to be 0.5, 0.5, 0.5, and 0.5 for your p hats and q hats, which is super rare. But in that case, I guess it would be the same. But our answer here is it's definitely going to be a larger sample size. Okay. All right. Suppose when we were doing number 9, instead of using confidence level number 2, we had used confidence level number 1. Would your sample size have been larger, smaller, or the same? Well, that's going to depend on what you got for your confidence levels. So my confidence level number 2 was 78%, which is small. Okay. If I had used this one, this is bigger and a larger confidence level. I want to be more confident, means I'm going to need a larger sample size. Okay. So if your number 1 is larger than your number 2 on page 579 for number 4. If this one's larger, then you're going to circle larger. If confidence level number 1 is smaller, then you would circle smaller. All right? Okay. All right, now we've got that. Now we're going to talk about hypothesis testing. So, hypothesis test for M&Ms and Skittles. You want to conduct a hypothesis test for the difference in proportions of M&Ms and Skittles. So, if that's the case, we can use the same exact results when we test it against confidence intervals over here, except they're changing the color on us, which is, so we're going to have to retest everything. So sorry about that, but we want to look at the largest difference color. So in this case, which one did you circle for number 2? I circled green. So now I'm looking at green. I'm just writing that so I keep track of which p hats and q hats I'm looking at. You want to conduct a hypothesis test for the difference in proportions of M&Ms and Skittles for the largest difference color. Verify whether all the requirements are satisfied for conducting this test. Okay, so again, both samples need to be random. They need to be independent of each other. They need to be independent of their populations. And they both have to be normal. Okay. Are they both random? Yes. Both samples are random. Because every M&M and Skittle had equal chance of getting sampled, right? Being in my samples. Okay. Or being selected, however you want to word it is fine. Okay. Are the two samples independent of each other? Yes. We have two groups measured once. Okay. All right. Are the two independent of the population? In that case, I need to check 20n less than capital N, 20n less than capital N. And we already did this. This is 20 times 140, which is 280, which is less than all M&Ms. And then this one is 20 times 238, which was, what was that one? 4760, which is less than all skills. Okay. Normal is where it's a little different, but not much, because now I'm not looking at yellow anymore. I'm looking at the color that had the largest difference. So I am looking at green in this case. So I have 140, my p hat for green, 0.164, my q hat for green, 0. Oh, no, not 0. It's 6. Okay. That gives me 19.19, bigger than 10. And then my other one, for green, for Skittles, and PQ for my second sample would be 238. For green, it was 0.227. Q hat in that case, 0.773. And the calculator is 41.8, which is bigger than 10. So are they both bigger than 10? Yes. Okay. All right. So we check that they're both random. We check that they're independent of each other. So two groups measured once or one group measured twice. Each sample is independent of the population. And then each sample is normal. So we are good. That means that we can do our hypothesis test. So regardless of whether you got yeses and nos, okay, test whether there is a significant difference between the proportions of M&Ms and Skittles that are the largest difference color. So I'm looking at green. You might be looking at something else, but I'm just writing that there so I remember which P hat and Q hat to use in this huge table on the front page. At the level of significance. So we're looking at level of significance, not confidence level. Level of significance is a small number. So for me, it was 0.087. Okay. All right. So our hypothesis, our null hypothesis is that the probability of a green M&M minus proportion of green Skittles equals 0. Okay. You may see it written as PM equals PS. That's fine. Either one is fine. Okay. Our alternative hypothesis is that proportion of M&Ms, proportion of Skittles, and am I doing greater, less than, less than, or not equal? We're just looking if there's a significant difference. So a significant difference could be greater or it could be less. So we are looking at a two-tailed test here. And that's usually what you are going to be looking at when you're doing two samples. It's usually going to be looking at not equal. Okay. There's sometimes where we'll compare them as greater, but your alpha is going to be your level of significance that you had from question number 5. Mine was 0.087. So whatever you got from question number 5, whatever random number you got on a StatCrunch, that's going to be your alpha. Okay. So I need to get my Z0. Now, what page do I want to look at for this? So in this case, am looking at proportions. I'm looking at two samples. So what page is that? So hypothesis test for a single proportion. Nope. That's for if I have one sample. Single mean. Nope. Test difference between two independent proportions. That's what I'm looking at. I need page 264. The other pages that we still haven't talked about are mean of matched pairs. We mentioned that a second ago when I was talking about married couples, and then two independent means. Okay. But for our case, we need what's on page 264, which says we do stat, proportion stats, to sample with summary. Okay. So I'm not going to write out the formula. The formula is not listed here. It just says find the test statistic. Okay. So that's at least a little nice when you're doing these chapter 11 ones, is you don't have to write out that giant formula, because it actually is really big when you're looking at two different samples. So, all right, so I'm going to come over here to StatCrunch, and I need to do stat proportion stats to sample with summary. How many did I have for the first color? So I'm looking at green. Whichever number you circled for number 2, that's the color you want. I had 23 greens in a total of 140 M&Ms. For my Skittles, green was 54, and I had 238 Skittles. Are we doing hypothesis testing or confidence intervals? We're doing hypothesis testing, where P1 minus P2 is not equal to 0. Now, it does allow you to change this, but when you're doing hypothesis testing for two different samples or two different populations, um, we're only going to be looking at where it's equal to 0. Okay. So, so you're going to leave that one fine. There it is. And then not equal. Okay. And we'll hit compute. And that is going to give us our Z statistic, which is negative 1.45. How many decimal places? Yeah, we'll do 4 decimal places. 9. Okay. All right. So there's my Z value. And that's going to give me my p-value as well. What was my p-value? 0.1445. Okay. Now this is a two-tailed test, so I'm going to shade both sides of my normal curve here. These two numbers together add up to that. Compare my p-value to my alpha. 0.87. So in my case, my p-value is bigger than alpha, so I do not reject. Now your numbers, your alpha might be different is going to be different from mine, because you got a random number out of StatCrunch. Your p-value is going to be different from mine, because you had a different color that had the biggest difference. You had different p hat and q hat for those, right? You have different numbers. So I do not reject the null. Maybe you will, maybe you do reject the null. Okay. Either way, we're going to write out our conclusion. If you rejected the null, you would say there is sufficient. I did not, so I'm going to say there is not sufficient evidence. There is not sufficient evidence to support the claim that what was even the claim I was looking at? The claim that there is the proportion of green M&Ms and green Skittles is different. The proportion or percent, I'll say percent. The percent of, I'm looking at green. You might be looking at something else. Green M&Ms and green Skittles is different. Okay. There's not sufficient evidence to support the claim that the percent of green M&Ms and the percent of green Skittles is different. Okay. All right. Now, usually we don't know the p-value, the true proportion p-value for the population, okay? For either population, okay? If we're looking at two different populations, in this case we're looking at M&Ms and Skittles, okay? But one of the nice things about this project is we're cheating a little bit because we actually do know the true value. We do know that the companies make the same number of each color, which means that M&Ms have a green proportion of 16%, right? 1/6, and Skittles has a proportion of 20% green Skittles, and we know that those two numbers are different, okay? So in this case, we did not reject the null. That doesn't mean that we accepted the null hypothesis. It just means, so we're not saying that these two proportions are equal, okay? We're saying that our test in this case was not sensitive enough to detect a difference, okay? If our alpha had been a lot bigger, or if our sample size had been bigger, we would have had a much better chance of telling if there was a difference. Because, like, okay, so 16 and 20%, those are different numbers. But think about it like, what if it was 10% and 10.1%? Those are very close to each other. They are different, but to be able to tell that they're different, you would need to be looking at it through a microscope, okay? Because they're very close to each other. They're off by 1/10%, okay? So in this case, uh, we don't know if the percents are different. That's what I'm saying here. There's not enough evidence. There is not sufficient evidence. Okay. It just means that if I wanted to support that claim, I just need to get more evidence. I need to do a bigger sample size, which we calculated earlier, right? I would need to, change some things about my experiment. Okay. All right. That is all I have for the day. If you have questions, please don't hesitate to reach out. Otherwise, I'm going to post this recording right now, and I hope you have a good weekend.